Okay, we have a series, and this one has two factors here. We've got n and n+3 in the denominator. That's telling us we've got to split it. So the way we split that is with partial fraction decomposition. With partial fraction decomposition, in the case where you have two linear factors, you have a plus b. And by linear, we mean that we just have n here and n with the other factor. We wouldn't have n squared. If we had n squared, it would be bx plus c over over whatever thing squared we had, over whatever squared thing we had. But in this case, we have two linear factors. That means this is n+3, this is n, and this has to equal 3 in the numerator there. So now we could cross multiply. We get a times n+3 plus bn equals 3. Distribute this, we get an plus 3a plus bn equals 3. Now we get the terms that have n together over here, and we have plus 3a. These are the two terms, so that's a plus b. A plus b multiplied by n plus 3a have to be 3. So this has to go to 0. This has to go to 0 for the reason being that we don't actually have a term with an n up in that numerator. So this n here must disappear because we need 3. We need 3. So that means that a plus b, which is the thing being multiplied to n, has to go to 0. So we have a plus b equals 0. Therefore, 3a is the only thing that could be 3. 3a equals 3. That gives us a equals 1. And if a equals 1, and we have this relation here, then b equals -1. So now we could plug in these values back into here, and we have 1 over n, and we have -1 in there. So this is how we're looking now. This thing right here is the same thing as this. That's what we wanted. Just get it in a different form where it's split. So now that we have this thing split, we can actually start plugging in values. And that was our goal, to split it and plug in values. So with the series, obviously we're adding. So we have all these terms at different indices, but they're all just addition. And this would go on, in our case, forever because of the infinity there. So let's plug in the first n equals 1, and we know we start at 1 because it says right here. So n equals 2, n equals 3, n equals 4, and we could go on really. We could plug in n equals 5 plus n equals 6 plus n equals 7. And so we would just literally just plug this in. We would go 1 minus 1/4. Then this would be 1/2 minus 1/5. 1/3 minus 1/6. 1/4 minus 1/7. And now we could start to see the pattern. We can start to see the pattern that we're just adding a number in the denominator on both sides. So here we have 1/5 minus 1/8. And then we have 1/6 minus 1/9. 1/7 minus 1/10. And so do things start to cancel out? Well, they do. They do. They just seem to be taking longer than normal. So if we plug in n equals 8, let's go ahead and do that just to be symmetric here. We would get 1/8 minus 1/11. But the point is, things do cancel out. This negative cancels out with this positive. 1 negative 1/5 cancels out with this positive 1/5. We've got 1 negative 1/6 with this 1/6, negative 1/7 with this 1/7, and 1/8 with this negative 1/8. So things will cancel out, but sometimes it just takes longer than normal. Sometimes you just need like the first few terms and you see, oh, everything's going to cancel out. But don't get discouraged. I mean, if you have to plug in 8 terms, you have to plug in 8 terms to see what's going on. And then you can expect what will cancel out and what won't. So we could tell already that this is going to cancel out because the next term over there is going to be 1/9. And so this pattern is always going to repeat. You're eventually going to get to 1/10 over there on this side of the formula. So that's going to cancel out. The things that are never going to cancel out are these first 3 guys. Like, they've missed the boat. They're just not going to be canceled at any point because the negatives are just increasing at this point in the value of their denominator. So you're never going to get to like 1/2 or 1/3 or 1/1. So we have to store these special values in our sum here. We've got 1 plus 1/2 plus 1/3. And this is what we're saving, and we're going to take the limit as n approaches infinity of whatever this is, plus its behavior near the end of this series. So now let's look at the behavior near the end. So the behavior near the end is one of panic for humans. But for this series, we have to actually look at how it looks. And the way we do that is by putting in n-1 or n-2 in replacement for n. So say this is the very last term over here. The very last term would be 1/n minus 1/n plus 3. Then the term before that would be if we had plugged in n-1 instead of n. So that would be 1/n minus 1 minus 1/n minus 1 plus 3. This would be if we had plugged in n-2 for n. And that would give us n-2 plus 3 there in the denominator. This would obviously be if we had plugged in n-3. And so this is really what we're doing with these guys is just plugging in numbers and seeing how they look. At the end, you just have to remember that you have to be a little more algebraic about it and leave the n and just subtract from the n. Subtract these integers. So we could see that stuff does cancel out. It's like this is negative 1/n. You've got the positive 1/n over here. This would be the negative 1/n. This gives us positive 1, n plus 1. This gives us plus 2. And so you always want to look for the positives and the negatives. When you have this symmetry between positives and negatives, they're going to cancel each other out. So, but you have to make sure that you don't get confused with the ones that are being subtracted inside as opposed to being multiplied, the negative being multiplied into it. For example, this is not going to cancel out with this. They kind of look similar, but they're not. going to cancel out, or this one with this one. So you would really have to go back more terms to start seeing the other stuff starting to cancel out. So this would be if we had plugged in n minus 4, and we get minus 1 over n minus 4 plus 3. This would be 1 over n minus 5 minus 1 over n minus 5 plus 3. 1 over n minus 6 minus 1 over n minus 6 plus 3. So this would give us n minus 3. N minus 3. This would give us n minus 2. N minus 1. And now we can see this one goes away with this one. This one goes away with this one. And we can assume that this pattern would have continued all the way back at this point. Like, you could tell that that entire thing is just going to keep canceling itself out. And so in this case, the guys that miss the boat are this guy, and this guy. And really, this is something that you should have known, that there were going to be 3 terms. There's a trick to it based on the fact that we had 3 terms here. So you didn't really need to be all confused. Like, I was all plugging in all these values and having you look at that. But really, you should know that it's just going to be the 3 terms. So as soon as you know what side of it gets canceled, you know it's going to be this side that gets saved. I have 3 terms initially that were saved, so it's going to be 1, 2, 3. So those are the guys that survive. And so let me rewrite this. We have 1 plus 1/2 plus 1/3. 1 plus 1/2 plus 1/3. And we're adding these terms. So we have negative 1 over n plus 1, negative 1 over n plus 2, and negative 1 over n plus 3. Now we take the limit as n approaches infinity of that. We take the limit as n approaches infinity, and that will give us 0 in that denominator. So we have 0 in those denominators because obviously infinity plus 1 is infinity, infinity plus 2 is infinity. We're just subtracting infinities. We're subtracting terms which have infinity in the denominator, which gives us zeros, which we're subtracting. And you take the limit of a constant, and it's just a constant. So our answer is 1 plus 1/2 plus 1/3. And you could simplify that if you want.